Hello, good day. The problem being addressed here is detection of deepfakes or classification of deepfake images between a data set using a data set of real images and generative adversarial neural networks images. So the data set has 140 images. So what I did here is that I first mounted the data set, and then I extracted the dataset from the zip file. After that, I used the image generator. To load the dataset while it will be trained, and also to augment the dataset as well. As you can see here, it managed to locate two classes, different classes from the data. So the data I was using was already pre-processed. I already had the data split into test, train, and validation data set. And then I created the model architecture. It's a sequential model which is built from scratch. I didn't use pre-trained models or use transfer learning. And then I compiled the model using sparse calculated cross-entropy, and then I also, to count the number of steps, I used the number of images in the dataset divided my batch size, which was 128. And then because this is a large dataset, it means that there was a problem the problem I encountered during training is that I would reach the runtime limit of colon. So instead, I decided to save the model at each epoch using weights. So as the model was being trained for like 20 epochs, it was being saved at each epoch. And after that, I used the validation generator or to compare with my train generator during training. And finally, to evaluate the model, I used the test generator, and I achieved an accuracy of 90%. And then I finally made a plot of my training accuracy and also my validation accuracy compared with, and also another plot of my training loss with my validation loss for the model. As you can see, they are not too far apart, so I can see that my model was not overfitting. I also made a prediction of the first image, and also made a prediction of the 9 different images. As you can see, my model managed to get, of the 9 images, managed to get 8 of them correct and only missed 1. And then finally I saved my model, and then loaded the model and made a prediction for 1 image, which was of label fake, and it managed to get the predict correct. So the goal here was also to serve to develop an API which will be used to serve this model of mine to client applications. So I then went on to develop an API. So this API was being used to load. It will load the model which I downloaded, and then I would use it to classify images. So this API can be served to bots, can be used in mobile or web applications. So I then deployed the API to Heroku, and I used GitHub for version control. So here I had the API on Postman. So since it's running, I can first try it on the deployed version of the API which I had deployed to Heroku. So I can just select a photo from my computer, and then it